Edward Christopher Wente had a long and fruitful career at Western Electric Bell Labs from 1914 to 1954. One of Wente's first assignments was improving the quality of telephone audio. In 1916, he filed a patent for a telephone transmitter, which we now know as the condenser microphone. This first design was fairly crude, but had remarkable performance compared to the carbon mics of the time. His 1.9-inch diameter capsule was capable of reproduction beyond 15 kHz, astonishing in a day when most 78 RPM acoustic recordings topped out around 3 kHz. In all, he was granted 36 patents and was awarded a Technical Academy Award in 1936 for his multi-cell horn design. Nearly 75 years ago, Harvey Fletcher and Weldon Munson, two Bell Labs engineers studying aspects of subjective loudness, changed the world's understanding of the hearing process. By asking a large number of people to compare the volume of two tones to a standard 1 kHz tone, and then averaging the results from the group, Fletcher and Munson showed that hearing is frequency selective. The phenomenon was referred to as the equal loudness contours. Fletcher and Munson's pioneering work laid the groundwork for creating industry-standard measurement curves, including the classic A, B, C, and D weighting filters that we know of today. In the late 1920s, audiences would watch any film where the lips moved in sync with the projected image. But once the novelty wore off, consumers started noticing the poor sound quality accompanying those pictures. Dissatisfied with the 5 kHz bandwidth systems available at the time was MGM sound department head Douglas Shearer. Known as the Shearer horn, the system used a large multicellular horn coupled to James B. Lansing's new Model 284 compression drivers. Low end was handled by a W folded horn bin loaded with two 15-inch Lansing woofers. Several units could be stacked for greater bass output. The Shearer horn began the age of modern sound systems, launching an entire new pro audio industry with an awareness for fidelity. In 1935, clock manufacturer Lawrence Hammond introduced his first tone wheel organ, but had no idea that more than 70 years later, his groundbreaking instrument would still have a major effect on musical styles. Initially, the Hammond organ was intended for the church and home markets, but it was the debut of the semi-portable, meaning only 400-pound, Model B3 in 1954 that brought this instrument to the forefront of jazz, R&B, and the emergence of rock and roll. The B3 was the right instrument at the right time, but its soulful versatility and great voicings, with Don Leslie's rotating speaker design, made the instrument a mainstay in every genre of pop music. A half-century ago, the development of cell sync recording eventually turned the recording world upside down. The impetus for multitracking came from Les Paul, who modified a tape deck with an extra head and was doing sound-on-sound recording as early as 1949. However, the technique was risky. One bad pass and the recording was ruined, and each additional pass added noise and distortion. With the concept for an 8-track in mind, Les Paul met with the special modifications team at Ampex, which started the project in 1953. The task required designing new record, play, and erase heads to achieve exact sync for monitoring previous tracks while overdubbing new ones. Ampex engineer Mort Fuji felt it could be done, and the first 1-inch cell sync 8-track went to Les Paul 2 years later. Ironically, an Ampex attorney felt the concept was obvious engineering and non-patentable, so no patent for multitracking was ever issued. Telefunken's U47 and ELA M series models are among the most highly coveted vintage microphones. However, Telefunken never built studio mics and outsourced manufacturing to companies such as Neumann and AKG, who made models with the Telefunken name. In the 1950s, Neumann U47s sold in the USA were distributed through Telefunken. Eventually, Neumann established its own North American distribution and stopped supplying U47s to Telefunken. Telefunken asked AKG to create a multi-pattern tube condenser that, like the U47, had its pattern control on the mic body rather than on the power supply, and the result was the ELAM 251 and ELAM 250. All used CK12 capsules employed in AKG's famed C12 microphones. Nearly a half century after its introduction, hundreds of Telefunken ELAM 250 and 251s are in use worldwide and are still prized by engineers for their smooth vocal reproduction. But credit should be given to AKG for designing this timeless, enduring classic. In 1960, Neumann launched the U67, a 3-pattern tube microphone that was essentially intended as a replacement for the U47. Designed by Neumann's Dr. Gerhard Boré, the U67's great sound and modern tapered shaft body made it an instant success. In 1966, Boré's team was asked to create a solid-state version of the U67, and the transistorized U87 was unveiled in 1967. The U87 used the same K67 capsule as the U67 and did not require a bulky external tube power supply. In 1967, Richard Heiser, a research engineer at the Jet Propulsion Laboratory of the California Institute of Technology, published a paper entitled Acoustical Measurements by Time Delay Spectrometry. The article described TDS, a technique for measuring loudspeakers in reverberant, real-world spaces without requiring an anechoic chamber. Unfortunately, the horsepower to perform such computations in near real time using 1960s technology was unavailable. But Heiser's concept of TDS drew wide acceptance. Eventually, Heiser's TDS concept went big time. In 1983, Crown's Techron division unveiled the TEF System 10, the first portable TDS analyzer measurement system. Acoustical research would never be the same, as for the first time, complex, on-site measurements of systems and spaces were possible from a commercially available product. In the early 1970s, Neville Thiel and Richard Small published their findings regarding the relationship of loudspeaker parameters to low-frequency performance in vented enclosures and showed simple methods of measuring them. Among these were the driver's free air resonance, electrical and mechanical cue, DC resistance, efficiency, piston area, thermal power rating, and others. The effect of the Thiel-Small research was dramatic, not only influencing manufacturers to provide more details about the drivers they built, but also bringing about a new era in the predictability of loudspeaker response based on enclosure volume and port dimensions. Today, the Thiel-Small parameters are adopted and provided by nearly every raw loudspeaker supplier. In the mid-1970s, URI founder Bill Putnam was dissatisfied with the sound of the Altec 604 monitors in his United Western studios. Working with URI's Dean Austin and Dennis Fink on ways to improve the 604, they replaced the Altec stock multi-cell horn with a wider dispersion design. Engineers mixing on the system were enthusiastic about its sound, and URI decided to produce the monitors as a commercial product, with the URI 813 debuting in 1977. These large double 15 monitors were ideal for the larger, higher SPL control rooms of the time. Putnam sold the business to Harman in 1983, who a year later debuted the all-JBL component Model 813C. But in its various forms, the URI 813 was the most successful, large-format studio monitor ever made. The Lexicon 224 was not the first digital reverb, but the 224 and its later 224X and 224XL cousins were among the most popular studio reverbs in history. The 224 story began when a nuclear physicist, musician, and classical recording engineer, David Griesinger, started working on a digital solution to artificial reverberation. Griesinger showed his prototype to Lexicon founder Francis Lee, who bought the invention and asked Griesinger to help refine the product. One of Griesinger's concepts was creating a remote control for parameter adjustment and program access, and the Lexicon 224 debuted at AES in 1978. The music industry was forever changed at the 1979 New York AES show with the introduction of the TEAC Model 144 Porta Studio, an integrated 4-track cassette recorder and 4x2 mixer with pan, treble, and bass on each input. Perhaps the most famous Porta Studio recording of all time was Bruce Springsteen's 1982 Nebraska album. Originally cut on a Porta Studio 144 with a couple of Shure SM57s, it was originally intended to be a demo. However, the boss liked the feel of the songs so much, rather than recut them, they became the master tracks. For most musicians seeking a sketchpad device for recording musical ideas and demos, the Model 144 was a runaway success story with a legacy of thousands of artists and engineers today who made their first multi-track recordings on Porta Studios. In the late 1970s, Sony launched a program to provide professional users with tools to support the consumer digital audio revolution. In 1981, as Mitsubishi began delivering its X800 digital 32 tracks, Sony countered with its PCM 3324 digital audio stationary head 24 track, which was 2 years from shipping. The original 44.1 and 48 kHz 16-bit PCM 3324 weighed 440 pounds, but had a maximum recording time of 65 minutes. Even with its $150,000 price tag, the PCM 3324 found early adopters such as Stevie Wonder, Neil Young, Frank Zappa, and remote trucks, and a new industry emerged offering digital rentals. Debuting in 1983, just months after the announcement of the MIDI spec, and offering new and varied tonal textures, Yamaha's DX7 was the right synth at the right time. But the magic behind the DX7's FM synthesis engine was discovered in the early 1970s by Dr. John Chowning at Stanford University. In the mid-1970s, Yamaha licensed the technology and spent nearly a decade working on the project. When the DX7 launched in 1983, users were amazed by its purity of tone and its ability to mimic certain instruments, such as struck percussion, chimes, and electric pianos, as well as its cool synthesizer sounds. The DX7 also marked the beginnings of custom VLSI integration into musical instruments, making it affordable as well. During its short tenure, Yamaha sold a then unheard of 200,000 DX7 synthesizers. In 1985, under the leadership of Andy Moorer, Lucasfilm's The Droid Works showed its SoundDroid workstation at NAB. The product was amazing, but was years ahead of its time and far too expensive for the typical studio. In 1986, former DroidWorks executives Bob Doris, Jeffrey Borish, and Mary Sauer left to form Sonic Solutions. Some months later, Andy Moorer joined the Sonic Solutions team, and the company debuted No Noise, a Macintosh-based system that applies proprietary DSP to eliminate broadband background noise, like tape hiss, and record surface noise, as well as AC hum, camera whine, and other ambient noises. Recognized for its use in restoring tens of thousands of recordings, forensic tracks, movie and TV soundtracks around the world, No Noise was honored with an Emmy Award for Outstanding Technical Achievement by the National Academy of Television Arts and Sciences.